Dear students, welcome to the course on Statistical Methods for Psychological Research Part 2. In this lesson, we are going to discuss about overview of statistical inference on testing of hypothesis. What we are going to learn in this lesson? Let us look at learning objectives. After completing this module, students will be able to understand the description and overview of statistical inference, understand the notion, purpose, significance, importance and testing procedures of the parametric hypothesis with suitable orientation, and apply practical orientation on few test statistics in parametric tests for small and large sample sizes. Let us start the beginning with first part lesson, in which you will learn the overview on the statistical inference. Statistical inference can be classified into two broad categories. One is estimation of parameters and second one is testing of hypothesis. Coming to the estimation of parameters, point estimation and interval estimation are two categories, whereas in testing of hypothesis, parametric testing and non-parametric testing are the two categories. We are going to discuss all these now. Purpose of statistical inference is it provides some important values that are available in the population, such as mean, size, variance, etc., and their overall effect under the estimation. It will formulate statements on whether the study provides evidence to reject or retain a research hypothesis under testing of hypothesis. Now, theory of estimation is a major part of statistical inference, in which it is a branch in statistics that provides numerical values of the unknown parameters of the population. This is on the basis of the measured empirical data that has a random component. The parameters describe an underlying physical settings in such a way that their value affects the distribution of the measured data. This is a process of guessing the underlying properties of the population by observing the sample that has been taken from the population. The idea behind this is to calculate and find out the approximate values of the population parameters on the basis of sample statistics. Now, the second part is testing of hypothesis, in which the purpose of hypothesis testing is to test whether the null hypothesis, that means the null hypothesis is mostly no difference or no effect, can be rejected or approved. If the null hypothesis is rejected, then the research hypothesis can be accepted. If null hypothesis is accepted, then the research hypothesis is rejected. In the hypothesis testing, a value is set to assess whether the null hypothesis is accepted or rejected and whether the result is statistically significant. So, a critical value is the score of the sample drawn from the parent population that decides against the null hypothesis. The probability value, mostly denoted with alpha, on rejecting the true null hypothesis is used to assess the significance of the statistical test. Now, coming to the point estimation, it is usually concerned on defined as a functions that can be used to find the approximate value of particular point from a given population parameter. The sample data of the population is used to find a point estimate or a statistic that can act as the best estimate of unknown parameter that is given for population. Consistent of good estimator or the criteria of a good estimator, there is a 4-part criteria in which consistent is one of the parts. So, the estimator has to be consistent. What it means that the larger the sample size, the more accurate the estimate. This means parameter will be guessed properly if the sample size is large. Another criteria for a good estimator is that unbiasedness. The expected value of the observed value for various samples equals to the corresponding population parameter, then you can claim the estimator is unbiased. Sufficient means an estimator that covers complete information regarding the population parameter, then you call it as that estimator is sufficient. Efficient means an estimator in the set of consistent estimators having the minimum variance is the most efficient estimator. The ratio between the variances of most efficient estimator to the specific estimator under study is called efficiency. Now, coming to the interval estimation and the confidence intervals. What do you mean by interval estimation? It is something like a kind of statistical inference in which we search for an interval of the value that contains the true parameter with high probability. Then what is confidence interval? It displays the probability that a parameter will fall between a pair of values around the mean. Confidence intervals measures the degree of uncertainty or certainty in sampling method. Statisticians often use p-values in conjunction with confidence interval to measure the statistical significance. Confidence intervals are most often constructed by either using 95% or 95% confidence level. Parametric testing of hypothesis is something like a hypothesis basing on the parameters. A parametric test relies upon the assumption that the data you want to test is approximately normally distributed. When the data needs to be symmetric, it is of normally distributed data. A parametric hypothesis test is a statistical hypothesis test which assumes that the sampling distribution is known and depends on a fixed set of parameters including the hypothesized population parameter and standard deviations. So, coming to the non-parametric testing of hypothesis, it is or experimented that do not require the underlying population for assumptions. So, it does not rely on any data referring to any particular parametric group of probability distribution. Non-parametric methods are also called distribution free tests since they do not have any underlying populations. Let us summarize the part 1 of this lesson. In this part, we discussed about statistical inference, in which there are two parts: theory of estimation and testing of hypothesis. Further, theory of estimation is discussed as point estimation and interval estimation. Testing of hypothesis is discussed as parametric and non-parametric testing. Hope you have enjoyed the part of this lesson on statistical inference. We will proceed to the second part of the lesson in the next session. Thank you.